Hi, boys and girls. It's Mr. Yates, and I'm here with Miss Garcia. Today, this video is about the Wednesday spiral math for Wednesday, April 15th. We're going to be checking that one today. Miss Garcia is going to be jumping in with the odds, and I'll be helping out with the evens today.
All right, so number one says, Connor is filling a 15-gallon wading pool. On his first trip, he carried 3 1/12. Mr. Yates, I'm sorry. Oh, hey, hang on.
Sure, do you want me to
My
zoom in?
face is covering it. No, it's good.
Oh.
I'm just going to move myself down. There we go.
Okay.
Okay. It says, on his first trip, he carried 3 1/12 gallon of water. He carried 3 5/6 gallons on his second trip and 3 1/2 gallons on his third trip. Suppose he carries 5 gallons on his next trip. Will the pool be filled? So for your guys' answer sentence, you can just say blank for your yes or your no. Well, I guess in a way, yeah. Because you're gonna either need your not in there possibly too. So yeah, be filled. Blank, the pool will be filled.
So it's either going to be yes, the pool will be filled, or no, the pool will not be filled.
Yes. So is what we're going to have to do is we're going to have to add our 3 1/12, our 3 5/6, and our 3 1/2, as well as our 5, because they want you guys to add that 5 in as if he did take those 5 gallons. So make sure that you did include that 5 gallons right there.
Ms. Garcia, I just want to go ahead and double check to make sure I've written everything down correctly today. So I've got 3 1/12 gallons, yes. And he carried 3 5/6 gallons, and then he also carried 3 1/2 gallons. And then I guess there's a final 5?
Yes.
Okay.
And 5, yep. And boys and girls, make sure that you're lining everything up just like Mr. Yates is doing, as well as writing them vertically. You have your whole numbers in one line and then your fractions in the other. All right, so let's go ahead and solve this out. So I'm looking at all of these fractions and we don't have a common denominator. So we're gonna have to make a common denominator and we're gonna use the number 12. So we are going to change our 5/6 into 12, into having a denominator of 12. So we just carry over that 1 from the 3 1/12 because it already has the denominator. And then just like Mr. Yates is doing, we're gonna have the 5/6, we're gonna multiply by 2, and remember what you do to the top, you have to do to the bottom, so that becomes 10/12. And then you have your 1/2, and you're gonna multiply both your numerator and your denominator by 6 to give you that 12. And then 6 times 1 gives you 6. And then with the 5, you don't have to do anything with it because it's just a whole number, so you're gonna add that when we add our whole numbers. So let's go ahead and add all of our numerators only, because when we add fractions, we don't add our denominators. So you should get 17 when you add all of your numerators together. And so that is not in simplest form. So remember, boys and girls, you need to be simplifying all of your fractions. So is how we simplify that. We are going to go ahead and divide 17 by 12. So we are going to have to think, how many times can 12 go into 17? It can only go in once. And then 1 times 12 gives you 12. When you subtract, you end up with 5. And so your new simplified fraction is going to be, or mixed number is going to be 1 5/12. So that is going to be in simplest form because you can't simplify your 5/12 anymore. So you have that. And then our next step is going to be to add our whole numbers. So you have 3 plus 3 plus 3, which gives you 9, and then add your 5, which gives you 14. But boys and girls, don't forget to add your 1 from your 1 5/12 to that 14. So when you add that together, you actually get 15 5/12. And looking back at our problem, it says that the wading pool is a 15-gallon wading pool. So the answer should be yes, the pool will be filled. So because 15 and 5/12 gives him 5/12 more than what the wading pool can hold. So it will definitely fill it.
Great. All right. I'm going to go ahead and we'll move on down to number 2. I'm going to write the phrase as a numerical expression. The phrase is subtract. So I'll write here the phrase as a numerical expression. Oh, you can't see that, so I should probably move it up. The phrase is a numerical expression is, and I'll go ahead and take a look here. There's my phrase right there. Subtract 15 from 24, then divide by 3. Boys and girls, don't fall into the trap. A lot of times we'll see this here and we'll think that that's going to mean 15 minus 24, and it doesn't. It's a trap. Really what this means is we're going to take the number 24 first, and then we're going to subtract 15 from it. Because this is subtracting and it is the order of operations, normally I would subtract second. So I want to make sure I put this in with parentheses to remind me that I'm going to subtracting it first, because that's where it comes into in the actual phrase. There's a little bit more left here. It says then divide by 3. So what I'll do is then I'll add the dividing sign and I'll have 3. You don't need to solve it. All I'm asking you to do for this one was just to write the phrase as a numerical expression in parentheses 25 minus 15, or subtract 15 from 24 divided by 3. And that's exactly how you write that as a numerical expression. We'll go on down to number 3. Let me go ahead and erase that little mark right there, because it keeps popping up.
While you erase that, that last question, it reminded me of when Tucker, hey buddy, shout out to you, when he came out to me in class and he was like, Miss Garcia, what's 1,000 plus 7 times 0 or something like that. it like, I don't know why that jogged my memory, but Tucker, good times, buddy. All right. On to number 3. It says, write the power as a product of the same factor and find the value. And what they are going to be, what we're going to be working with is 3 to the 7th power. So you guys can say, would you say that they could just write out that like number sentence? Yeah, okay, that sounds, okay.
Yeah, it just says write the power as a product, so just write it like that way, it's fine.
Okay, cool. So boys and girls, keep in mind this isn't 3 times 7. This is going to be 3 times 3 times 3 times 3 times 3 times 3 times 3, 7 times. So you're going to want to do what Mr. Yates is doing and make sure you're counting those 3. Make sure there's 7 of them. And then they wanted you guys to multiply these all together to give you your product. And when you guys multiplied this out, you guys should have gotten 2,187 as your product. Yep, just like so. So make sure you guys have that just like Mr. Yates has.
All right. We're going to go ahead and move on down to number 4 right now, boys, or number 5. Oh, no, sorry, number 4. And while we do that, I am trying to get rid of that little dot that keeps coming back. So hopefully this is gone now. So now we're going to zoom out, back, and we're going to round the decimal to the place indicated. I'm going to zoom in just a little bit so I can see this a little better. So it looks like we're going to be taking 980 and 79 hundredths, and we're going to round it to the ones place. Since we're talking about the ones place, I'm going to underline right here the ones place. And I'm going to do that on my work right here so I can see. So I'm going to take, and I'll take 980 and 79 hundredths. I want to underline the ones place because we're going to be rounding to that. So what I'll do is I'm going to point to the arrow, or point with the arrow to the next place value, which is the 10th place. The tens place is 7. So because there's a 7 in there, that means that it is 5 or more. That means I'm going to raise the score here on the 0 in the ones place and go up 1 more. So now, by rounding this, I'm going to end up with 981. So 981. I don't need the decimal after that. I can leave that go. So what I'll do here is I'll write as my answer sentence, 980 and 79 hundredths rounded to the ones place is 981. All right, great. All right, let's go on. We'll move on down to number 5 now.
Alrighty, so number 5 says, oh, just gotta give Mr. Yates a quick second real quick.
All right.
It says, what value completes the sentence? So they want you guys to figure out 45 liters equals blank milliliters. So, and you guys are more than welcome to just write that as 45 liters equals blank milliliters as your answer sentence. So we have to move our decimal. I always write out the whole King Henry died unexpectedly drinking chocolate milk, but that's always just how I've done it. And so when you move from liters to milliliters, you're gonna be moving your decimal 3 place values to the right.
Why are you going to do that, Ms. Garcia?
Because milliliters are definitely bigger than liters, so you want to be, I just use like a chart. I've always used a chart because it's the 1,000 milliliters is in 1 liter. So you have to move that decimal 3
So,
positions to the right.
Right, because we're going to be multiplying times 1,000.
Mm-hmm.
And like Ms. Garcia is saying, we don't have to actually multiply that out. We just do some easy mental math. We
So
add,
you guys get 45,000.
and I'll move it over, and I'll put a comma in here. And then we'll be ready to go ahead and put that into here.
Yep, so 45 liters equals 45,000 milliliters.
And I'm really looking forward to, in the next couple lessons, we'll be, Ms. Garcia talks about her King Henry died while drinking chocolate milk. Is that how it goes?
King Henry died unexpectedly drinking chocolate milk. Yeah.
That is a great way to remember how to convert values with the metric system, and we'll be introducing that in just a few more lessons, boys and girls. So on number 6, I'm going to be multiplying. I'm going to be taking 2 and 1/6, and I'm going to multiply 3 and 2/3. Now, when I multiply mixed numbers like that, the first thing I got to remember is that I can't do this until I actually turn these mixed numbers into improper fractions. So I'll be looking at 2 and 1/6, and I can multiply 12. 2 times 6 is 12, plus 1 is 13, so it becomes 13 over 6, which is my denominator right here. Then I'm going to multiply that by 3 2/3, but again, I have to turn that 3 2/3 into an improper fraction. So I'll take 3 times 3 is 9, plus 2 is 11. So it becomes 11 over 3. So by going across right here, I take 6 times 3, that's going to equal 16 as my denominator. Ms. Garcia, did you already multiply out 13 times 11, or I can go ahead and do it right now? I just wasn't sure if you
Yeah, I got 143.
Okay, so I'll go ahead and put that right here as 443 as my numerator.
I'll double check.
Oh.
13 times 11. Yeah, 143. Okay.
Excellent. Great. Now, one thing I notice about this is that it's an improper fraction. This denominator is way smaller than the numerator up on top. So because the numerator is improper, because this is an improper fraction, I need to turn it into a mixed number again. So I'll be doing that right over here. And oh, sadly, I've kind of run out of space here for really some nice dividing. So I'm going to go ahead and take this 143 and divide it by 18. Go to my back page over here. And I'll just do some nice sideways dividing. 143. Oops. I don't have an eraser on this one, so I'll go ahead and change this right here. 143 divided by 18. Going sideways, if you have lined paper, is always a great choice to make sure you avoid tragic calculation errors. So I'll go ahead and put down this. I can't multiply here. 143 divided by 18. Oh, I'm going to go, let's try 6. 18 times 6. That's too small. I can already tell. 108. Let's try 7. Okay. 56, 5.
Oh, Mr. Yates,
Yes.
you want to multiply 18 times 7, not 108.
Oh no! The dreaded copier. Dun, dun, dun. I'm glad you noticed that, Miss Garcia. It's always
But it
good
is 7 if it helps you.
What's that?
7. It is 7 though.
Okay, well, we'll take it from there. And Ms. Garcia, thank you for demonstrating that it is always important to check your work and always important to look for copy errors or calculation errors because you might overlook them. All right, so we're going to go ahead here and 18 times 7. And Ms. Garcia, we multiplied 18 times 7. What did we end up with?
I got 143.
Oh, exactly. Okay, 143.
Oh no, I'm
exactly.
sorry. I was looking at the wrong thing. My bad, guys. 126. My bad.
Okay, it's okay. So I'm going to go ahead and put 126 right here. And then what I'll do is I'll go ahead and subtract. 13 minus 6 is 7. 3 minus 2 is 1. So I end up with a remainder of 17, which is smaller than 18, which is okay. Let me move that over so you can see it. So now my mixed number is going to be 7 and 17 over 18. Now it seems like 100 years ago when I started this multiplication problem, but I'm going to go ahead and remember where I was at, right here with my number sentence at the very bottom here with number 6. And I'll put that that was, the product is 7 and 17 over 18. Make sure you check to make sure you got the same thing we did, and you're good to go. We're going to move on now to number 7. I'll zoom in just a little bit so you can see that one. Okay, Ms. Garcia.
All right, so for number 7, they want you guys to divide 5.9 divided by 10. And if you guys are did a number sentence, you guys are more than welcome to do that. Mr. Yates is doing it. So for this one, you don't have to actually divide it. Since we are dividing 5.9 divided by 10, we are actually going to be moving our to the left one time to show that place value of our division. And so you guys should get 0.59 once you guys go to the left.
Mr. Yates, heard you say left, and then I still moved it right. So I would put that as a copy error. I meant to do it. All right, so we're going to go back again since I'm dividing.
Yes, because you want to make the number smaller when you're dividing. So it should be 0.59. There we go.
Great. Thanks for catching that. All right. Now the last one is the 2 fastest times in the past 20 years for the girls' 200-meter run at Clarksville Elementary School are 27 and 97 hundredths seconds and 27 and 93 hundredths seconds. At yesterday's track meet, Claire ran 27 and 99 hundredths seconds. Was her time faster than either of the 2 fastest? How do you know? So I'll go ahead and I'm going to write, well, I think my answer sentence will be she was faster or she wasn't faster than either 2. So I might hold off on my answer sentence so I know a little bit more, or you can leave it blank like we did with the earlier one. But what I'm going to do now is just take a look. I'm going to have to, now there's a couple tricky numbers here. 20 years and 200 meters. If you were a number monkey, you try to figure those numbers into the word problem, but you don't need to because they're really not relevant at all. The most important numbers here are going to be 27 and 97 hundredths for the first fastest run, and 27 and 93 hundredths for the other fastest run. Now Claire, she ran at 27 and 99 hundredths seconds. So what we're going to do is we're going to be comparing these numbers. So on my work right here, I'm going to look at 27 and 97 hundredths. I like to line up my decimals here so I can make sure I'm comparing them accurate. 27 and 93 hundredths. And then we're going to put here Claire at 27 and 99 hundredths. And I'll label this one Claire so I just know what I'm talking about here. Claire. All right, and I'm having some issues with spelling today. All right, so boys and girls, when I look at this, I now know that Claire had the same amount of time with 27 seconds. That's still the same. And she still had the same amount of time with the 9 hundredths or 9/10. But here's where the difference is. This person ran 700 seconds. Claire ran 900 seconds. This person ran 300 seconds, and Claire ran 900. So it looks like to me that Claire, even though she ran pretty fast, did not run as fast as either one of these two scores. So her time was not faster than either two of the fastest. So I'm going to put here. And you can make the answer sentence anyway, but I'm just going to say that Claire did not run faster. Now the key phrase here in this sentence one phrase you may look at is, how do you know? And you want to be able to tell me because. Claire did not run faster because 27 and 99 hundredths, which is her time, is greater than 27 and 97 hundredths and 27 and 93 hundredths. So Claire did not run faster because 27 and 99 hundredths is greater than 27 and 97 hundredths and 27 and 93 hundredths. And I'm going to circle that word because right there. And make sure you have a because sense. It could be a little different, but you really do want to have the same essence that tells me why Claire did not run faster. All right, boys and girls, that's our Spiral Math for today. Thank you for checking, and please remember, make sure you fill out a Spiral Math survey so we can see what you did and where you did well. Thanks, boys and girls.